In sections 4.3 to 4.5, our goal is to be able to use a limited amount of information about side lengths and angle measures to prove triangles are congruent. We will also be able to use coordinate methods such as distance and slope and algebraic methods to prove triangles are congruent. Recently, we discussed how to tell when triangles are congruent. Are these triangles congruent? Now, you might not have this on your note sheet, but just take a look at these triangles. I see these three sides have the same marks as these three sides, and these three angles have the same marks as these three angles. Therefore, I conclude that all parts from this triangle are congruent to all parts from this triangle, and therefore, yes, these triangles must be congruent. How about in this picture? Notice that I've left out this angle and this angle. Is this enough information to say the triangles are congruent? Well, before we said that when figures are congruent, all of the angles have to be congruent to all of these angles, and all of these sides have to be congruent to all of these sides. Do I know if these angles are congruent? That's one of our questions today. How about this amount of information? Two sides congruent to two sides. Is this enough information to say the triangles are congruent? How about these three sides congruent to these three sides? Well, before, we had to give a scenario like the first one. We had to say all of these parts are congruent to all of these parts before we could say the triangles are congruent. Well, today, I'm going to show you some shortcuts that help us to prove two triangles are congruent without needing all of the information. And here's our first one, the side-side-side congruence postulate. If three sides of a triangle are congruent to three sides of another triangle, then the triangles are congruent. What does that look like in a picture? Well, let's say side BC is congruent to side DE. Side AB is congruent to side EF, and side AC is congruent to side DF. That is enough information to say this triangle is congruent to this triangle, and therefore we can write a congruent statement. Make sure we match up the corresponding parts that are marked when we attempt to write this statement. Now, how do I want to write this first triangle? Maybe I go alphabetically. Triangle ABC is congruent to, but when I do the second triangle, I have to make sure I match corresponding parts. So if I went A, B, C, from A to B to C, I went here, and then I went here. I went over the double slash side, then over the single slash side. What path is going to take me over the double and then the single? This way and then this way. So that means I have to start at F. So I'm going to say triangle F and go towards E and then D. The point here being we have only three sides congruent to three sides, then the triangles will be congruent. That is enough information. Now maybe you're asking yourself why? Why is that enough information? Well, ultimately, this is something we can explore in class, but just to give you a quick visual, I've got three sides here congruent to these three sides. If I try to change the side lengths, it won't change the fact that I can't make a different size triangle. If I try to make the three sides different, it's going to create a different size triangle. Let's go back to our list of postulates and theorems. Now we write for short Sss Congruence Postulate, but remember what that means. Side, side, side. Three sides congruent to three sides. Similarly, the Sas Congruence Postulate, or the side angle side congruence postulate, says that if two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the triangles are congruent. Well, what does that mean? Two sides and the included angle. Let's start with just two sides. So I'm going to take the two sides that I first marked here, BC congruent to DE and AB congruent to side EF. The included angle means the angle between. The angle that's made by connecting those two sides that have marks. This side that has a mark and this side that has a mark is connecting at angle B. B is the included angle. Similarly, this side that has a mark and this side that has a mark is connecting at angle E. E is the included angle. So according to side, angle, side, these two triangles can now be proved congruent. I can write a congruent statement just like I did before. How do we do it when there are angles and sides marked? Let's take a look. Triangle ABC, I might choose to start, is congruent to, now just like we did before, let's examine the path we take. ABC. So I go over the double slash side, hit the marked angle, and then go over the single slash side. Same idea that we did in the previous example. Follow the same path by looking at the marks. So once again, triangle FED. The point that we want to see here is that we have a limited amount of information. This time it's two sides congruent to two sides. The included or in between angle congruent to the included angle. Let's look at a couple more that are very much like each other. Angle side angle versus angle angle side. So again, these are shortcut letters, but it's angle side angle versus angle angle side. Now the question is, how does that look different? Here's how it's described. If two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then the triangles are congruent. Versus angle angle side says if two angles and the non-included side of a triangle are congruent to two angles and the non-included side of another triangle, then the triangles are congruent. So how does that look differently? Two angles in the included side versus two angles in the non-included side. Well, both of them have two angles. So let's start with the angles. I'm going to mark angle A congruent to angle F and angle B congruent to angle E. Notice that I'm using different types of angle marks. So I've got two angles. Now the included side. What does that mean, the included side? Well, included before meant between. Still means between, or we can think of connecting. Connecting this angle to this angle is this side. Connecting this angle to this angle is this side. That's how angle side angle looks. Now I'm going to mark for angle angle side the same angle A congruent to angle F and angle B congruent to angle E. Now, the included side is the side between or connecting. The non-included side is the side that's not between or not connecting. So if we look at the side that's connecting from A to B, that's this side. So I need to have marked one of the other sides, such as BC and ED. Notice how this is the side connecting angle to angle. Therefore, this is a side not between, an angle, angle, and a side. Similarly to how we wrote the congruent statements, I can do that here. Let's just try it for one of them. Triangle A, B, C. If I go from A to B and then to C, let's talk about the path that we took. We went from single angle mark to double angle mark and then over the slash. So similarly, single angle mark to double angle mark and then over the slash. So ABC is congruent to triangle FED, but for different reasons because of the path we took with those corresponding marks. Now, in case you haven't noticed, we've been using theorems, postulates that use three letters, such as SSS, SAS, ASA, and AAS. So hopefully you've gotten the idea by now that it has to be a combination of three things congruent to three things. Well, what about the combination SSA? Does that work? Let's look at a picture. So in this diagram, notice I've got two sides and an angle that's not between these two sides that are marked. So these two sides are congruent to these two sides. The included angle would be the angle connecting these sides, this angle right here. So it's not the included angle, it's this angle over here. Now let's go back to this picture for a moment, or SSA that I have here. So what I'm showing you is side congruent to side, second side congruent to second side, but instead of the angle being between, like SAS, like this one, it's not between, it's after. So these are different, two sides and an angle, but where the angle is placed is very important. If the angle is not connecting or included, so included means here, included means here, between or connecting. If it's not, so instead of it being up here, what if we put it not connecting, like down here? So let's go back to that picture so you can see what that's going to look like. Side, 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 and an angle not between. Well, these look congruent, but look at another way that I can keep this same congruent mark and see something not congruent. So I went from an acute triangle that has these two congruent sides to an obtuse triangle. Still has these two congruent sides, but notice that because this angle wasn't fixed, the side could go here or the side could go here. The point is, side-side angle is not enough information to prove that triangles are congruent. Now, there is one exception when it does work. Real quick, before we get to this exception, here's a helpful way to remember that side-side angle won't work. Spell this word backwards in your head. Yeah, creates a bad word, doesn't it? Let's never say that bad word, and we'll remember to never use SSA. So let's check out. Here's a time when you're going to ask the question about SSA again. HL congruence theorem. HL stands for hypotenuse leg. When do you have a hypotenuse? When you have a right triangle. So here's the theorem. If the hypotenuse and leg of a right triangle are congruent to the hypotenuse and leg of another right triangle, then the triangles are congruent. So I have to have a right triangle, so I'm going to put a right angle in this picture. The hypotenuse and leg have to be congruent to the other hypotenuse and leg. So I'm going to make the hypotenuse congruent to the hypotenuse, and one of the legs congruent to one of the legs in the other triangle. Well, if you're looking at this and you think about what we just talked about with SSA, you might be asking yourself, well, here's a side, and here's a side that have marks, and here's the included angle. This angle that has an angle mark is not included. So isn't this a case of side, side, angle? Isn't this the bad word that we're never supposed to use? Well, when it's a right triangle, we have no other option for how to swing that non-fixed side. So therefore, when it's a right triangle, SSA will work. But that's why we don't call it side-side angle. We have a better name for it, HL, the hypotenuse leg congruence theorem. But we have to have those two sides for a right triangle. For more information and to see these postulates or theorems in action, try visiting this website at Math Open Reference. So let's talk about which are the two combinations that we don't use and we haven't shown as postulates or theorems. Side-side angle we talked about, spells the bad word backwards is an easy way to remember it. Check out this website to see how that doesn't work. Angle, angle, angle is the other combination that we didn't use. Let's look at why that doesn't work. So here's a picture of three angles congruent to three angles. I can grab onto one of these vertices and make this triangle bigger. I still have, see how angle P and angle A are congruent to each other? All three angles are congruent to all three angles, yet if the sides are not fixed, if I do not have at least one fixed side, I can make the triangle as small or as big as I want, and still the angles will be the same. Now it'll be the same shape, the same kind of triangle, it'll just be different sizes. But congruent triangles have to be same size and shape. So SSA and AAA are the two we don't use. We have to have at least one side, and we can't spell the bad word. Let's look at some examples. Determine which postulate or theorem proves the triangles are congruent. Then write the congruent statement for the triangles. Now, the first thing I do when I look at these pictures is ask myself, is there any other information that I know I can mark? I also ask myself, do I have at least 3 things congruent from this triangle to the other triangle? And I see 2 sides congruent to 2 sides and an angle congruent to an angle. So yes, let's list those things that we look for. Do we have at least 3 things? Do we have at least 3 things marked congruent? And if we don't, can I mark anything else? So that's one thing to ask myself. Then I'm going to mark anything that's marked as a side with an S, anything that's marked with an angle congruent mark as an A. Here's another side congruent mark, so I'm going to call that an S. If I have an angle that doesn't have a congruent mark, I'm going to put an X there. If I have a side that doesn't have a congruent mark, I'm going to put an X there. Here's another angle that doesn't have a congruent mark. Now, just doing that to one triangle, now I can think about which postulate or theorem is it if I try to follow the path around the triangle. Meaning, I'm going to start at one of the things that is marked and choose to go one way around the triangle or the other way around the triangle. If I cross over more than one X, I know I can't take that direction. So I can only cross over one X. So I can't go this way, I'm crossing over too many X's. So let's go this way, side, and then I hit an angle, and then I hit a side. So this is the side, angle, side postulate. And now I can write the congruence statement to say what are the triangles that are congruent. Triangle. Now, any way you want to, we can mark this. Maybe the way that I went around the triangle, TKV. Let's try that. TKV. Congruent to triangle. Now, let's make sure we follow the path that we took. T to K went over the 1/ side and then over the 2/ side. So 1/ to 2/ goes that way. Triangle HMJ. Would you like to try the others on your own? If you'd like to walk through it together, I'll do that now. So first thing I ask myself, do I have at least 3 things marked? Side, side, and an angle congruent to a side, and an angle. So I have that. Next, let's label everything we have marked. A side congruent mark, a side congruent mark, and an angle congruent mark. Now this one is a right angle, but it's still a mark that's the same as this one. So it's still an angle mark. Now I'm going to mark with X's anything not marked. This angle doesn't have a mark, this angle doesn't have a mark, this side doesn't have a mark. So now I'm going to pick a path to take, starting at any S or A. Maybe I'll start at this S, and I'll say, okay, if I want to go this way, I hit an X and I hit another X. I can't go on a side that hits more than one X. So I'm going to take the path that doesn't hit more than one X. Here's an X, so keep going. So I hit another S, and then I hit an A. So is it SSA? Well, we can't use that. That's the bad word backwards. But SSA is right when it's a right angle. If I have a right angle, that means I'm going to use HL if I see the SSA. I have the hypotenuse marked with the hypotenuse and a leg marked congruent to a leg. So I can use hypotenuse leg, and now I can give my congruent statement. Triangle BCD U, so I started at the right angle and went over the 2 slash side. I'll do the same thing here. Right angle over the 2 slash side gives me triangle FEW. Now what can we do in this one? First of all, I see this triangle right here has only 2 things marked. So maybe I say I don't have enough information. But remember the shared side. This side, RQ, is congruent to itself in both triangles. So I'm going to show that it's congruent to itself using the reflexive property. Now we have 3 congruent marks and the same 3 congruent marks in the other triangle. Now let's focus on one triangle as we label our angles and sides that have marks in them. So I'm going to label, this is a side mark, this is a side mark, and this is a side mark. This angle doesn't have any mark, neither does this, nor this. Now I'm going to pick a place to start and go around the triangle. This one's not so tricky because it's all just S's. S, S, and another S. So I see that it's SSS, and I can write my congruent statement. Triangle PQR, maybe? Doesn't matter how we write the first one, as long as we match up the corresponding parts in the next one. So P to Q went over the 1 slash side, and then over R, over the 3 slash side to get to R. So 1 slash to 3 slash takes us N to R to Q. N, R, Q. Let's look at a couple more examples. State the third congruence that's needed to prove triangle DEF is congruent to triangle MNO using the given postulate or theorem. Mark each picture. So it's given that segment FE is congruent to segment ON. All right, I've marked those congruent. Angle F is congruent to angle O. I've marked those congruent. That's just 2 items so far. They're telling us we need to use the AAS, angle, angle, side. Well, I only have an angle and a side. I need 2 angles marked. Well, do I pick this one or do I pick this one? Remember that it's supposed to be the side not between the 2 angles. So if I were to pick this angle, I have an angle, and the side that connects them. So it can't be this one, it's got to be this one. Well, we can check by doing our S's, A's, and X's. Here's a side mark, here's an angle mark, here's a side angle mark. This side doesn't have anything, X. This angle, nothing, X. This side, nothing, X. If I choose to start my path with the A, and I want to go this way, I hit an X and I hit another X. No good. So let's go this way. I hit an X, but then I hit another letter. I hit an A, and then right after that I hit an S. So angle, angle, side works when I use that angle. So let's write down in the blank what was the third thing we had to mark. Angle D congruent to angle M. Angle D congruent to angle M. Let's see how that is different from this one. Given that segment DF is congruent to segment MO, and angle F is congruent to angle O. This time, we want to use angle, side, angle. So here's an angle, here's a side. I need the angle that comes right after that side. It's going to be that angle. So see how I have an angle mark, a side mark right after it, and an angle mark right after. That's the included side. So it was angle D and angle M. Finally, take a few minutes to write a summary. Write the 5 shortcuts we can use to prove triangles are congruent. Those would be our postulates and theorems. Then compare and contrast angle, angle, side, and angle, side, angle. How are they different? How are they similar? See you in class.